No. It's the beach ball of doom and despair. Now, either my computer's just being really slow right now and it'll stop any second, or something's gone terribly wrong and it's stuck in an infinite loop that's never going to stop. Now, why can't my computer just figure out if it's stuck in an infinite loop and stop if it is? Now, as we start to answer this question, imagine for a second that we had an all-knowing demon friend, a demon who could predict anything in the universe. There are some on this plane that call me Bob. Now, our friend Bob knows the positions and momenta of every particle in the universe, and using this information, he can figure out anything that's ever going to be. He was dreamt up by the French scholar Pierre-Simon Laplace in 1814, and it seems like answering a simple question like, is my computer ever going to stop looping, should be a piece of cake for Bob, right? Not so. As it turns out, this is one of the most famous problems in theoretical computer science, and spoiler alert, Bob isn't going to be able to do much. It's called the halting problem, and it goes like this. Could we ever build an algorithm that takes any other program as an input and tells us correctly if that program is ever going to stop running? Wait a minute, how do we get from demons to programs? Well, a program is just any machine that takes an input and gives us an output. This input could be anything, a number, a string, a function, even itself. In our case, Bob claims to be this function, so we feed him any other function and he tells us if it stops or not. Now at this point, our demon friend Bob is feeling pretty confident in his abilities, but we can outwit him. Suppose we define a program, call her Ada. And Ada decides she's going to make some mischief by asking Bob about herself. Now, Bob's still feeling pretty good about himself. Mwahahaha, you are no match for my fortune-telling abilities. But suppose Ada asks him now, am I going to halt? And Ada thinks in her head now, she's going to do the exact opposite of what Bob tells her she's going to do. If Bob says she's going to halt, she'll just run forever. And if he tells her she's going to run forever, she'll stop. Now, Ada can't possibly be running forever and stopping at the same time. We see there's a paradox, and so Bob vanishes in a puff of logic and self-reference. Well, so what if we can't solve the halting problem and Bob isn't as smart as he thinks he is, you ask? Excellent question, and one that Alan Turing was asking himself in the 1930s as he laid the foundations of modern computer science. Well, maybe he didn't really care about Bob, but that's besides the point. One of the strangest consequences of the halting problem is that there exists a whole class of problems called undecidable problems. That is, problems we can't answer with a yes or no in every situation. And this leads us to a really weird thought. There are fundamental limits to computation. You could have a computer with infinite memory and all the time in the universe, and there are still problems in math and computer science that you still wouldn't be able to answer. No matter how fast AI grows, there are going to be things that it just can't grapple with either. And on a philosophical and perhaps physical level, can we ever tell if the universe is going to halt? So, can Bob predict everything? Maybe not, but he does ask us some very unsettling questions about the computers that govern our lives.